All right, last example of this lesson, example 4. Determining the number of x-intercept using A and Q. So I've already kind of alluded to this, and we've talked a lot about just general traits and predicting up and down and where the vertex is. So we're going to see that here. In our first example, our Q value is below the x, or below the x-axis. It's down here at -3. My A value is opening upward. It's positive. So that means that I need to have 2 intercepts. Okay, so when Q is less than 0 and Q is greater than 0, that's when we have 2 intercepts. In this case, Q is actually 0, so it's right on my x-axis. Still opening up, but opening up and opening down is not going to change anything in this case because I'm still only going to have 1 intercept. We see that here. There's 2, we see kind of there. Disregard the fact that these are horrible in terms of curviness. They're just sketches. Okay, so we have 1 intercept when Q equals 0. Finally, if Q is below 0 and my parabola is opening downward, I get 0 intercepts. So I could describe that as Q is less than 0 and A is less than 0. Can you think of another scenario where this would be the case? Okay, well, if you think about it, potentially, if my vertex is above my axis and then opening upward, I get the same problem. So when Q is greater than 0 and A is greater than 0, we also run into that scenario. So when in doubt, you can always sketch it out like I have here, but these are our general rules that we can use to predict using A and Q. So give your homework a shot. Make sure we are really comfortable with this whole vertex form because it makes it just like really nice to be able to graph like this. In addition to that, the whole idea of transformations is a prevalent one in grade 12 pre-cal, so it's nice to get a little bit of a head start in grade 11.